So, and one more story. Over a year ago, I attended an evening workshop where not only computer scientists attended, but also other fields. And I was talking about my favor of doing experimentation with AI in programming. And the polite pause was, why is that? Software is now programmed by AI in 23 already, okay? So, okay, I thought, well, is it? Will it ever be? Or what are the prospects or limitations of using AI in software engineering and its automation? So, and that is what I planned for today. So I take a market perspective, industrial perspective on software engineering first. Then I get into recent research on using AI in software engineering. Then I head towards the AI assistance with so-called big models. I'll come to that later, and of course do a wrap up. Okay, for the market perspective, unfortunately, there has been a very recent study from Sopra Steria Next last week. They analyzed the market in 4 categories, including AI for software. And they state that AI for software has, together with AI for people, the greatest potential. And they showed quite some impressive numbers what will be possible. So it's about automating software engineering primarily in the financial services domain, healthcare, e-domain, e-commerce or media, and it's about 7 to 10% cost reduction, a lot of fewer bugs, and so on and so forth. That study is also supported by the Gartner study on the hype cycle for emerging technologies. In the 20s, we saw AI-assisted coding, AI-assisted engineering. Nowadays, so merged both into AI-augmented software engineering, and they expect that those AI practices will reach mainstream already in 2 to 5 years. So the plateau of productivity. And that by 27, already 50% of the software engineers will be AI and ML, machine learning powered. And they sort of say, sort it out a little more and talk about the top technology trends for software engineering, which includes not only the AI augmentation and software engineering, but also the platform engineering and other things. So those 2, they highlight. And they also say, whoever is not going to use AI later on, he or she will not make it. Okay. Then I looked further, for example, into the developer nation, which is a developer community sharing knowledge, basically. And they also do an annual survey. And the one from this year included first time also questions on AI. One question was, which of the following areas are developers actively working on? And there you see that AI assistance in software engineering is even ahead of Gen AI, right? And then other things. And next question has been, what would be the top 5 tasks that you have used AI-assisted development to complete the task you have in the last year? Here, only a third have replied. So the previous question was answered by over 6,000 people. Now we have over almost 3,000 people. And they say top is code generation, in particular suggestions for code snippets. Then this is followed by bug detection, fixing, code refactoring, and so on and so forth. So you can read it. Okay, so rather impressive numbers. Heading on, I looked into McKinsey. They looked into the potential productivity gains of using AI in software engineering. But first is important to see that there are different figures according to the task that needs to be performed. Then you see the dark blue line is task completion with AI, and then without AI and with AI. And the larger the gap is, the more gain is with applying AI. So, and that study says that developers with AI tools were 25 to 30% more likely to complete their tasks rather than engineers without assistance. And that documentation can better be supported than high complexity tasks. Heading on, I looked into the digital AI, which argues for AI assistance in software engineering. They do not only focus on the software development as a core, but also argue that AI can likewise help to accelerate software delivery workflows and to look into optimization questions. For example, in optimizing trade-offs or other decision-making problems. So a more complete picture is given here. So, and then let us get back to the developers community. GitHub has a very enthusiastic study on the potential productivity gains. It was already 23. They talk about turbocharging development with AI. And then they had some more subtle differentiations. They say that a less experienced developer will gain more, will benefit more than others. They also say that along the time, the impact of Copilot, so the suggestions Copilot provides will be adopted more, which leads then finally, and that I found very interesting, to not only faster developers, but happier developers. So happiness becomes an issue with this AI assistance. And then they had kind of comparative numbers as shown before. So there's faster coding. There is more fulfillment in the task completion. And overall, they talk about a 30% productivity enhancement with AI. And they then do some computation and say, well, there will be effectively 15 million more developers in the game by 2030 due to the AI assistance, which is also a good thing because we know how important software is and how much software needs to be developed also in the upcoming years. A little deeper into this study, they had also more fine-grained analysis how the developers look at their tasks, so what they would delegate or won't delegate to the AI, and you see the shift from the easy things, commenting code, code documentation, to code writing, code development. So the one with or without the AI. And it's interesting for those which are testers like me, testing is quite on top, so right after the documentation. So I could go on, but so to say, two more references. Google had quite lower numbers, so they talk about 6% gains only. So we have 6 to 35 somehow. JetBrains even said, well, it's more about doing a kind of pair programming with AI rather than doing the real coding tasks. So we don't know how it will go, but I think the numbers so far are already quite impressive. And I now get on to research and discuss a little more this perspective. So, of course, every research talk nowadays needs to ask ChatGPT, so what is AI? So it's about field of computer science focused on creating systems capable of performing tasks that typically require human intelligence. These tasks include reasoning, learning, problem solving, perception, language understanding, and decision making. They require large amounts of data for training, and their performance is measured in terms of accuracy and so on and so forth. And then often the AI comes with some ethical consideration. Here, the ethical, societal, and safety implications of AI are actively studied in research in order to ensure responsible development. This chart you might have seen. It's from Max Rosa. He is at Oxford University, economist and statistician, that, so to say, shows where we stand in comparing AI with human intelligence, although he argues it's a rather bad comparison because artificial intelligence is rather a technical one, so a technical that may supersede and do things a lot better than we could do. Just think about analyzing huge amounts of data where we are bad at. So, but you see that in the past 15 years, there has been a deep increase of the AI capabilities, and it supersedes our possibilities in rather simple things for language understanding, for reading comprehension, and so on. For more complex tasks, we are not yet there. So complex reasoning is very below code generation, math problem solving, and so on. So, and he and others argue not only about complex tasks, because AI is just repeating things we developed before, will likely be maybe below our possibilities, but that we need to seek for bringing the AI towards that they are better than us because of the things they can do. And of course, then at the end, the question is, will AI ever be able to engineer itself, right? And interestingly, ChatGPT replies with, is far from capable of fully engineering software autonomously. Which is, of course, it's always the extract of all the things we think, right? So be careful with what is put there. So this is not original, but it's derived, it's surveyed, so to say, from the AI. So we all together think that it's from being capable of doing so. But it highlights the things it can do. So it's again code generation, bug detection and testing, refactoring and optimization, but also assistance with software design. And then another question is the other way around. So what is it that AI would be unable to fully do software engineering? So what are the human capabilities being important in software engineering? And top is problem solving and logical reasoning. By the way, if you put the very same question for software testing, the capabilities have different order of prioritization, which is also interesting. So, and I won't read it up, but again, at the bottom, there is the ethical consideration that only we would be able to look at when developing software. Interestingly, I found also that our time management was added. So I would have expected that an automation would be better than we are, but let us leave it like that. Okay, now let's get a little deeper into software engineering. What is it? It's according to IEEE, ISO, and others, it's the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. So it's just the engineering of software. And if you look into this webbook, which is currently drafted into a new version, then you still have the software development lifecycle from requirements via architecture and design. They split it because architecture became so important these days, then into the software construction, testing, and maintenance. There are cross-cutting concerns like the quality issues or security issues, and it's about the management of the software engineering process and the software configuration. And then there are some outer aspects like the economics of software engineering and some bottom line foundations for software engineering. So as I didn't know how big the screen is, so I made it a little larger for you to read, but I think it was large enough. So a short review of the historical development of software engineering would show like that. In the early days, there was the NATO conference, 68, which coined the term software engineering. Then we had, so to say, first developments, how software engineering processes would look like, and the waterfall model was soon developed. Then a lot of methodologies developed, like object-oriented programming patterns in software designs, forming methods, but also software metrics. It went on to the agility consideration with the HR manifesto, but also with UML. It had on to open source and web technologies, then into continuous development and delivery. And finally, we nowadays talk about AI and automation and software engineering along the AI assistance, but also low-code, no-code, which is a new interpretation of model-based software engineering. And it's a lot about responsible software engineering, so about ethical considerations. Basically, if you look at it, and I will get into this in more detail, it's about applying AI either, so to say, in between text and code, back and forth. So it's for generation, it's for documentation, information retrieval, the other way around, and it's about sort of working on code artifacts like recommendations, doing static analysis, and so on and so forth. And that is the table I created. What were the recent developments in supporting software engineering with AI? And I think a good approach is to look if the AI support would help us in better understanding the software engineering tasks, in generating software engineering artifacts, or to improve software engineering artifacts. So the generation is, for example, from text to code. The improvement is from code to code. And I do not have time to get into all those papers, but I selected some of them to show you what, so to say, researchers are working on. For example, Kerner worked on AI-supported requirements elicitation and change process, which basically transform textual requirements into formal models. It uses EMF, and then it uses linguistic rules to talk about ambiguities, inconsistencies, incorrectness, incompleteness, and so on. And then the process provides recommendations for the requirements analysts to change or to add requirements. So this is a rather complete process they are describing. Another work is on architecture and design, so both on the understanding and generation side by Bart and others. They help to analyze the historical cases of software designs and try to translate the contextual information of the current project and compare it with, so to say, the past experience from software designs. And so they again come up with suggestions and design options so that the architects can choose between the various design options. With the code, we have tools like Graph Codebird. I don't know how it's pronounced, but it is so. So, of course, there's Bird, a Codebird, and a Graph Codebird by Google and others. They pre-train with several codes from different programming languages. They add data flow semantics and do not work only on the code syntax. And then they apply their tool for code search, code detection, code translation, as well as code refinement. So it helps in understanding, improving, as well as generating code snippets. So one more example for code generation is Word. So this is a paper on experiences with applying Copilot, which, so to say, analyzed 3 empirical studies, and they, so to say, highlighted what are good things with AI assistance in coding, which is not so good, and which is an in-between. But at the end, they highlight the growing importance of code review, because the more we work with recommendations on coding or architectural design, whatever, the more we get into the role of reviewing and improving things, right? So decisively choosing the options they are offering us. Well, testing, of course, there are a lot of examples as well. I choose the lens paper, which helps to link test results from different techniques in the terms that different tests has been derived, applying different methods, then they cluster again, and then sort of say provide classifications according to the test objectives, so that once again we are supported with in the selection and prioritization processes. Right? So they all help us in sort of say aggregating the combined knowledge of the community. And I think I have one more, yeah, with the software engineering process. Of course, there are also AI-based approaches that help for the overarching engineering process. And this is now a T-BERT framework by Lin et al. They help to find the trace links between source code and natural language artifacts. So, which is at the final end, when I need to, for example, maintain and further develop software. So how do they relate? How have code issues impact on the requirements and so on and so forth. One more. Okay, then it's the last one. So that by the speaker and others, that is about, once again, a test case approach or test result approach, but this time in continuous integration and deployment contexts, where they use the AI to give a fast feedback whenever the test results are there, so that the coders can sooner decide if or not to change the committed code. So by improving the continuous integration cycles. So this was really a rough run through. Some recent results. I wanted to highlight the AI SEER taxonomy by FEL because I evolved it further. It was presented in 18, where they differentiate the application of AI along the point of application. So if AI is being used in the process, in the product, or at runtime, they propose 10 levels of automation, which are quite subtle, and that's some headache to understand. For example, the difference between level 10, computer makes and implements decision if it feels it should and informs human only if it feels this is warranted. So I'm already confused by the term feels because there are no feelings. But and 9 is computer makes and implements decision, and also there's the blank missing, and informs human only if it feels this is warranted. So there are so subtle differences. Maybe it's too small, this difference, and they differentiate the AI methods with the AI types. Well, I thought maybe it's better to first think about the goal of application. So what should AI bring us? How it should transform software engineering with better tool support. So for the moment, I think the understanding generation improvement is quite helpful. Taxonomy. Then I think also the phase of application should be more fine-grained because the process is a lot larger than just the process. So I used a kind of the SWABOC aspects in this, and I also split it the operations side. And then with the autonomy levels, I think we are good off by taking a translation from autonomous driving to AI-assisted software engineering. So it's just 4 levels. If you think, wait, there are 5 levels. Yes, there again, there's too small differentiation, I think. For SE, I think it's enough to talk about the offering of options, of recommendations down to full automation, where I think that full automation, well, yes, is the version, but I guess we will just come to the partial automation. And then the AI methods, well, I feel better off with the symbolic, statistical, sub-symbolic differentiation, but this is, I guess, a matter of taste. Okay, this is the current status of AI assistance in SE, in my understanding. And now I'd like to, of course, turn to Sam and thought about what this has to do with modern, right? Okay, so let's try. So modern software engineering, in short, models are used to cope with the complexity in software engineering, with the complexity of software or of the process. It's also known to be model-driven development or model-driven architectures and other terms. But interestingly, while initially MDSE was top-down, so we a lot of thought about how to specify things in order to generate the lower-level artifacts. It's now becoming more and more also bottom-up, so that out of the lower-level artifacts, we do derive the structural modeling knowledge that is inside those artifacts. Looking up the status of available data for coding, this is just a snippet from Kibble about GitHub and others. There has been, I think, consolidation on the coding platforms, but it's steadily growing. And I found not only interesting that there are a lot of blank code lines. It's over 10%, quite some comments are in, and I found interesting that there are already quite a lot of structural information like JSON or XML, right? So, but it's not yet further analyzed. So now, looking back, what it has been in other papers presented before, the approach to use AI for software engineering, they sort of say translated the code structures into something that AI could work on. And for that, Alamanis and others come up with a naturalness hypothesis, saying that software is a form of human communication, such that software corpora have similar statistical properties to natural language corpora. So all the gains that have been possible with natural language processing is also applicable to code language processing, right? In addition to this hypothesis, Hamilton and others argued that it's very important to, so to say, extract the formal logic, the graph structures in software engineering artifacts, so that there is, so to say, a bottom-up approach, not only to work on code, but to work on data flow and other semantic structures embedded in the code artifacts, right? And this is explicit then by Pudari et al., which say it's really important to elevate abstraction levels such that AI can do more than just a syntactical comparison. So it's about semantics in the software engineering artifacts, which are important. Okay. Oh, so of course, well, here we need to stick the modeling hypotheses. Would be interested to hear your sort of say reflection on that. So I simply said, software is also, of course, a formalized communication between humans and computers, and also model corpora, like software corpora and natural language corpora, similar statistical properties. And those model corpora can likewise be used as the code corpora that we have. Which brings us to the opportunities of looking at AI in model-driven software engineering. And I argue first, it's about providing large amounts of also top-down models, which is already something that is heavily going on. There is I'm missing the word. There's a famous data set, Lincoln data set, where the modeling community joined forces to bring together all the important models being available. And interestingly, there is also a lot of analysis going on already, how much models are incorporated on coding platforms. Then it's about generating the models, including in the coding artifacts we can use from the coding platforms. So you might have heard that this big data term was coined into big code. Why I say there should be also big model. So, which brings me to the third opportunity to really form big models as a corpora by itself, so that we both can do more empirical research on model-driven software engineering, bless you, and to improve it further. And there's third, of course, then the application of AI on these model corporas that we are having already, or that we even going to improve. And I think the huge improvement is with the bottom-up extraction, because there's a lot in already, which then finally leads to my thinking that we will enter another phase of software engineering where we are using, maybe this time really intensively, models, and more intensively than before. And look, the taxonomy works again. So there is first work on using AI with models. It's not that strong, but there are some publications already. For example, the papers by Mangaro, Lear, and Sherban, they are about understanding available UML class diagrams, if they are bottom-up or top-down developed. So, which helps in getting a better understanding of the quality of these class diagrams. Or there's another one which tries to understand from images which types of diagrams are included, which is one step to then extract further the knowledge in from the code platforms. There is another publication by Baki and others, and Sarawi. They apply AI in order to support model translation. So they relate source models to target models and try to sort of say derive the inner knowledge for these transformations, so that they then suggest the model transformations which are suitable in a certain modeling context. And last but not least, there is a paper by Badur, which, so to say, try to apply AI in order to support the comparison of models, again, when analyzing large model sets. And they use it for domain analysis, so improving the models, also for repository management. So which models should be maybe updated or whatever. And then, of course, it's about model search to find most appropriate things where you could start from. So, which leads me at the end to, let's say, extending the timeline for software engineering. I did not use my 20-year-old slide where we say, well, computer science is always a history of abstracting programming concepts. So from functional to object-oriented to service-oriented to model-oriented. But maybe this time it's a kind of in parallel. We, so to say, do code by microservice architectures with model support. And this on large, let's say, coding platforms which have not only huge amounts of code, but also large amounts of models. So I think there will be less models, but it should be increasing. So this is my keynote for today. So I looked into the market perspective of using AI in software engineering. There are already quite impressive numbers, but they vary a lot. So we will see in the upcoming future how it will evolve. Then I looked up recent research results and came up with the AI for SE taxonomy. And last, I shared with you my thoughts about how combining model-driven software engineering with AI may be coming up with big models altogether. If you want to follow up, well, I will make the slides available, but you may also easily jump into the paper collection. I use Research Rabbit, and I made this collection publicly available. It was 50 references, starting already 87, but the majority, of course, is in the past 5 years. And that's it from my side. So besides Research Rabbit, I, of course, use Scholar and ChatGPT and DeepL to improve my language. And that's it. Thank you very much for the invitation once again.